Boom, boom, boom. Boom, 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 boom. Oh man. Da-na-na. Yo, what's up, Zorn? Come up here, Zorn. You have a mic? You wanna talk? Come talk. What's my stage chat not working? Mason plays. Who's Mason, dude? What's up, Ethan? Stop the music. Oh my god. Alright. Yo, what's up, Zorn?
I didn't even realize I was in this channel right now, but I'm
Oh.
going to stay.
Yeah, no, the stage. Are you familiar with Discord?
I am actually. I'm also the guy from TikTok. You just
Yes,
I use some question on TikTok.
Yes, I recognize the name, and I think you had the same profile picture or something, like W Cartman. That's cool. Yeah. So yeah, this is our whole Discord. Wait, so you found our thing through, what was it, the front page or whatever on TikTok?
Yes, exactly. But the invite link didn't work, so I just copied the link and typed.
Oh, did it not work? Oh, that's weird.
No.
Maybe I typed it in wrong or something. Was there's a link on our homepage? I think that one must work because I keep seeing people coming in.
Yeah, I used I went on your TikTok homepage.
There we go. That link.
And then
Yeah.
I used that link.
Good.
But when I clicked on it, I couldn't join
Oh,
for
weird.
some reason.
Okay. There's always like some weird technical shit that's going on. But yeah, dude, welcome. This is so as I was saying, so I think I give you like a brief, like I always give like a brief introduction on like, but TikTok only lets me like say so many things. Like the character count limit is like pretty absurd. I'm like, what? It's like only like 100 characters. I can't say shit, dude. But yeah, this is our Discord. So we're a nonprofit that like helps kids out with like math, science, whatever stuff they're in and whatnot. And I do that by one of the streams, which is, this is the office hour stream I do 3 times a week, where it's like an hour and a half, and people just post whatever questions they have in like their math classes, science classes, and I just go one-on-one, and I just tutor them in it. So like, here are like some example questions. I don't know, this you probably recognize. This is some physics, right? You know?
Well, I'm still in high school. This is my last year, so
Last
I
year.
don't know if I recognize it on it.
It's okay. Have you done any physics yet in high school?
Well, the school I am right now, it's a school like specialized on physics, so my main
Yes.
subject is technical physics.
Okay.
The subject I am doing right now in physics is like throws. So yeah, downward throw, up throw, horizontal throw,
Okay.
those kind of things.
Very cool. And you're looking at maybe like doing, so I guess next step is university, right?
Yes.
Yeah. And you want to do that somewhere in Germany, like Würzburg or something?
Yeah, so the very good university in like my state is Universität Heidelberg.
Oh, Heidelberg! Yes! Yeah, I've heard good things about Heidelberg.
I hope I get accepted, but you know, who knows?
Oh, well, you got to believe in yourself, dude. You know, you can do it, man. That's what I would say. Yeah, Heidelberg's cool. My ex actually went there for like a study abroad thing when she was at Pepperdine. Like a lot of U.S. students go to Heidelberg to, I guess, do an exchange year or something. There's a big castle.
Heidelberg, it's very beautiful, and
Yeah.
there's also a castle.
Yeah, it's very, yeah, I've never been. The only place in Berlin, sorry, not Berlin. The only place in Germany I've been is Berlin. Yeah, I had a great time in Berlin. I missed my flight because I partied too hard in there. But, so I had to stay another night. I was like, okay, another night, like eating donor, I'm here for it, dude. Yeah, okay, so cool. You found our Discord, that's great. So if you ever have any questions like in math or like science or anything you're doing, like homework questions and whatnot, this is a great stream where like I help people out with all their individual homework questions and whatnot. And then on Thursday, what I have, which I think you'd probably be more interested in, is I have an AMA stream. It's called Golden Hour, and it happens for like an hour, 2 hours. And that's like you know what an AMA is, like Ask Me Anything?
Okay, now I know. Ask me anything, yes.
Yes, AMA, it's a Reddit term, I think it is. So AMA's Ask Me Anything, and that stream, like, people ask me like whatever. You know, some people ask me, you know, oh, what's your favorite color, and like that's obvious, it's gold. But or they ask me, you know, relationship questions, or again, career questions are a big one too. Like, what should I go into if I want to do this, or you know, what was your thesis about Dr. Gold, and blah blah blah. And so that's because I think you were curious, I guess, in what like my whole like physics journey experience was, right?
Yes, exactly.
Yeah.
Because like when I look at universities in Germany, some physics programs are like kind of different. Like for example, looking at a university in Heidelberg, they obviously have experimental physics, theoretical physics, and then also like a math module, I think. But then when I look at University Stuttgart,
True.
they apparently also have first and second semesters like introduction to chemistry, and
Okay.
like chemistry, like I guess scares me but not
I
maybe that
teach a
it's
lot of
difficult.
chemistry. Like chemistry's
It's
not that
just I
bad.
don't want to do chemistry.
You
It's
don't want to do
just
chemistry.
yes, I don't find it as interesting as physics.
Yeah, so that's cool. Well, if you're interested in physics, that's great. Yeah, I guess there's a lot of different disciplines. I'm not super familiar on the European university PhD track thing or whatever. So I eventually did a PhD is what I did. And in the US, you go to undergrad and you don't really have to even pick what you want to study for the first 4 years. You kind of define, I guess,
Yeah,
like a major.
like that's also the case in Germany, as I've heard. Like the bachelor degree in Germany is like very strict. I'd say you don't have a lot of freedom to choose what you want to do, but that changes in master. So America doesn't have
Interesting.
bachelor and master, just undergrad and graduate or what?
Oh, interesting. Yeah, so that you that's so interesting. Like you come into university and you have to take these courses. You don't really have any like choice of like what you want to do. It's kind of interesting.
Not entirely. No, there's
But
like maybe
when you go into university, are you applying specifically for I want to be in the physics program at this university or I want to be in this program, or is it just a general kind of everything?
no, like you can still choose your subject that you want to study.
Okay.
And but when you choose to study physics, the bachelor degree is like you study everything in physics, from mechanics, electrodynamics that we're
Okay.
talking about, like the your timetable, I guess I should say, is very strict.
Thermodynamics. Yeah, it's every. I
Yes,
get
yes,
you.
yes,
So they make you take kind of a little bit of everything. Okay. That kind of makes
yes,
sense.
yes.
They do the same at U.S. universities. If you go into, for instance, a physics major, per se, in order to get a bachelor's in physics, you have to take quantum, you have to take thermo, you got to take dynamics. I don't know, whatever, all the classes and whatnot. And that's a good thing because what that does is that gets you a little bit of exposure to everything, so that you can then decide for your graduate program, which I know in Europe a lot of times you go get a master's first, and then once you have a master's, you go get a PhD. Is that correct?
Yes, you do bachelor's, master's, and then PhD.
Yeah. So in the U.S., you do bachelor's, and then you go straight to PhD. You get a master's along the way.
Oh,
But when you apply for graduate school, you're applying for a PhD program. And you don't necessarily have to know, for instance, what type of physics you want to do, because even in grad school, so my experience at UCLA, the first 2 years, you still took all the physics classes. So I had a quantum class, I had an E&M class, I had a thermo class, I had a mechanics class. So I had to take all of those my first year. And then you have what's called a comp exam, which is an exam over all of physics that you've taken the first year of grad school. And you have to pass that. And once you pass that, then you get to specialize in what field of physics you want. And then you have to pick an advisor. It's kind of how it works.
I think I remember one person saying, because I also watched German videos on the physics experience, I'd say it's not unusual for people to get a master's degree when they do their PhD. So like bachelor's, master's, and then maybe even a second master when they
Yeah.
do their PhD.
Yeah, so I had some foreign students that came in, right? International students that came into my PhD program, and most of them had masters. And I think, for instance, if you're trying to do a PhD in the United States, you probably need a master's degree from Europe, so that, or at least it helps you a lot, I guess, because at that point you kind of already know what you're going to be doing, and that's why they accept you, because they're like, oh, just plug them in. So yeah,
So I'm reading in your chat that I'm apparently occupying you with
no,
something else.
you're good. You're good. No, no.
Not even at all my intention.
No, you're fine. No, I like. Don't worry. No. I told him he's chill. Don't worry. Everyone asks questions and whatnot. I'm happy to to help you out and stuff. But yeah, if you want me to talk more in depth about like the whole my physics journey and everything, come by on Thursday. And then that's a more like chill. I mean, you can stay in this stream too, please. Like if you want to see me like teaching physics or math, like it's good to see it because you'll remember it later in life. You'll be like, oh, I kind of remember seeing that one guy go over this, on a Twitch stream. But if you want me to like really digress into like the whole PhD program and stuff, whatnot, come by on Thursday, and I'd be happy to just like talk all about that.
So
Cool.
I'm going to stay, and also I would like to stay the other time, but the problem is now in Germany it's midnight.
Oh
So
yeah,
which
it's
means
late.
during school days I can't stay.
Okay.
But luckily tomorrow I have school off, which means I'm going to stay.
Oh, okay, cool. Yeah, and dude, if you ever have any other questions, just send me a DM. You have my Discord now and everything. Yeah, and so I'm happy to answer any questions. You can always DM me. My DMs are always open. Cool.
Alright, thanks.
All right, nice meeting you, Zoran, dude. Yeah, stick by and we'll go over some questions. All right, let's go. All right, welcome everyone to the Office Hours stream. My name is Dr. Grohl, this is Actual Education, the stream that helps you out with math, homework, science, homework, all sorts of homework. Someone was asking me about like history the other day or something, and I was like, oh man, to me history is just reading a book or something. They were asking me some question about how like sovereignty affected the states in the Civil War. I'm like, well, I don't really know that because I didn't really read that, but you know, you should probably read it somewhere. But yeah, in terms of math and science, I got you guys. That's what I specialize in. That's what I got like a decade of experience teaching. Here, let me delete all these pages real quick. Okay, let's see. Where is Mason? Mason, come up the stage. Mason's new. So anytime we got new students, I try to answer their questions first. All the regulars and whatnot. You guys know how to work this Discord. For those that are new, because I know I posted something on TikTok the other day and it's been blowing like up a lot, which is great. I think it's because it's the school year and people need help with things, so I'm happy to help. But we have this Discord, and if you ever have a specific math or science question that you want to go over during one of our office hour streams, these are the streams where I help you out with homework. We have a help screenshots channel here, and the only thing you can post in this channel is pictures. The bot will not let you post anything other than a picture. So, and the reason why I have this is because I need some sort of organization. So if you ever have any specific math or science question, try to post it in this channel, and I'll get to them, like first come, first serve and whatnot. But if you're new to our Discord and you just found it and whatnot, see, you can't post text there. See, Noise is trying, dude. Noise is trying. Well, you can't do that. But this is totally this is totally cool. What's up, Ethan? Give me a second. All right, this is totally cool, Mason. You can post this here. This is because it's your first time. But in the future, if you have questions and you want me to answer them, post them in that channel. Just post this. A screenshot of this is perfect. This is absolutely perfect. Okay. All right, one sec. Oh, Mason, let's get you on the. Did I invite you? Do you want to speak on the stage? You can, Mason, if you want. Or you don't have to. It's okay. You let me get. I'm having trouble joining the stage. Yeah. Sometimes you have to leave the channel and then you have to come back into the channel. So try doing that. Try leaving the stage, coming back in the stage. Yeah. I don't know. Discord, fix your shit, dude. Okay. Then here, let me invite you. There you go. And it should have. Let's see if you can click it. There we go. Okay, now you're on.
Alright.
Cool, Mason. What's up? How's it going, dude?
Yes, please.
Did you also find us on TikTok?
Yeah, actually a while ago, like a year ago maybe.
Oh, cool, man. All right, good shit. All right, you got a physics class, I guess, right? This is what's going on? Yeah?
Yeah.
Okay.
Yep.
Here it says, oh, we're on space. Ooh, space. Says, Noise says, ew. It's chill. The mass of an equipment is 350 kilograms. The acceleration of free fall is 7.5. State what is exerted by the term weight. This is correct. This is a commonly misunderstood concept in physics. You know when you see like kilograms, right? What's another way you know how to weigh things, Mason? How do you usually weigh things? Or like what are the units you use?
Oh, it's the scale.
Good, yeah. And then usually you measure that in what? What's the units for it, I guess?
Oh, grams.
Grams, cool. Yeah. If you were in the United States and you stepped on a scale, it would be measured in pounds, right? I know, evil U.S. units, I guess. But but yeah. So people usually think that this is, for instance, a weight, and it is. But they also think that this is a weight, and technically it's not. And the difference is that this kilograms is what's called a mass, and the mass of something does not change regardless of where it is. Doesn't matter if it's on the moon, doesn't matter if it's on Earth, doesn't matter if it's on Mars or whatever. The mass is the mass. When we refer to the weight of something, which usually we measure in pounds, that is the force that something feels due to its mass and due to gravity. And so that's why they say here that weight is the force exerted on a body by gravity. It's the force something feels because of the gravity it's experiencing. Does that make sense so far?
Yeah.
Awesome, cool. All right, so do you know how to write an equation for what the force is on something due to gravity?
Wait. Force equals ma, I think.
Good. So you are right. So this is Newton's second law, which says that force is equal to the mass times the acceleration. That's correct. That is true. So if you want to say what the force of gravity is, that is going to be the mass times the acceleration due to gravity. We say like acceleration due to gravity, but this is also usually written as just g, is what we say. So let me move this out of the way. Sorry.
Oh, gotcha.
So instead of just ag, we're just going to say g. So this is the force of gravity is equal to the mass times the acceleration due to gravity. And this is what they call the weight. Okay.
Newtons, I think.
It is in newtons. Yeah, good. Yeah, forces are always in newtons. Unless you're in, the weird U.S. standard units. I think it's pounds. And isn't there like dynes or something? That's another unit. Dynes, D-Y-N-S, D-Y-N-E-S. There's some weird ones. Slugs. Dude, I love slugs. Do you guys know that slugs is a unit? Yeah, here you go. One slug is equal to 32.147 pounds. It's just like, what? I forget who came up with this thing, dude. It's probably some weird British person at some point. But let me see. Do they have newtons on it? What is a slug? Did they have it in newtons? No, they don't have it in newtons. Oh, I think slug is the mass equivalent is what it is. Okay, whatever. Anyways, I sometimes like saying funny things about the units we have. But yeah, this is in newtons. Okay, so if I want to find the weight of this equipment, what am I going to do?
You're gonna like multiply the mass by the gravity.
Good, exactly, yeah. So that's going to be mass, which is 350. And then what's the gravity?
7.5.
7.5, good. Yeah, that's the acceleration due to this planet, which I don't know what planet this is. I think the moon is technically like 3. So this is some weird planet. Kiss Killer says, is mass measured in
It's
atomic
1.6,
mass?
I'm not sure.
It is, yeah, it's low. It's low. Is AMU or something? Mass is just measured in grams, Kiss Killer. Just measured in grams. Okay, good. So yeah, this is just 350 times 7.5, right? Which, you can use a calculator for that because we don't, I could maybe do that in my head, but I don't think you're expected to do that in your head. Okay, so here, let me pull up the calculator we have.
Just 2,625.
Okay, let's check it out. 2,000 what?
625.
All right, let's see if you're right.
No, 2,000. No. Oh, yeah.
Yeah, 2,625. Yes, that's correct. Good. This is 2,625 newtons. Okay, that's what you put down for the weight.
Oh,
Do you want to know something else that's cool here? You can also calculate what's called like the apparent weight, which is how heavy this thing would feel like on Earth. Okay? Because if you say something weighs 2,625 newtons, right? That's kind of a hard number to picture. Like, I don't know what 2,000 newtons weighs. I'm just like, wait, what is that? You know? If someone says, I weigh 400 pounds, I know how many cheeseburgers, you ate. But if someone says they weigh like thousands of newtons, I don't really know. So do you know how to figure out from newtons how much something would weigh on Earth?
Like divided by 9.8 or something.
Good. Exactly, yeah. So if I take this 2,625 and then I divide it by 9.8, this will go back to giving me what's called like the apparent weight, or like what the mass on Earth would be. So if I take this number and I divide it by 9.8, this gets me 267, okay? Which is 266 kilograms. That's like apparently. So do you see how you weigh a lot less, right, on whatever this planet is compared to like how much you would weigh on Earth?
Yeah.
Yeah, awesome, cool. Does that answer your question?
Yeah, thank you.
Yes. You're welcome. Good job. Bum, bum. Yes, just divide by 9.8 or to get mass. Yeah, noise with minus 10, dude. Stop. Don't do it. 10, you're going to get people mad, dude. People are going to get upset at you. Yeah. Nice. Mason. One bond coin to Mason. Mason, when'd you join our Discord? Have you been on our Discord for a while?
I think it was like 2022 or something. I saw it on TikTok.
Oh, that's cool. Did I ever buy you a gift card yet?
No.
No? Oh, okay. So for those that are new, or so another thing we do, we incentivize you guys to like ask questions and whatnot and get help. So every time you ask a question on the stream, you get what's called a bond coin, and then once you get 10, like your first 10, I'll buy you like whatever gift card in gaming stuff. It's kind of like a little like reward system. So.
Oh, that's nice.
Yeah. So yeah, feel free like ask questions during streams and stuff, and you get prizes. Nice. Gaming. You're welcome. You're welcome, dude. All right, let me go through. Ethan, what's up, dude? You were saying hi to me. Sorry, I was in the middle of a conversation with someone. What's up? Or maybe Ethan left. I got all these pings. So many pings. Okay, but I'm gonna go through questions. Let me see. Oh, nice. What are you giving to me? What is this? Is this more physics but with linear algebra? What is this? What are you giving to me here, Noise? Dun, 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 dun. I have never in my life used the term dines or slugs, and I'm proud to be in the land where there are more guns than people. Hey, you're right. Yeah. There are more guns than people. I think there's more guns than people on the earth. No, it can't be that many. That's like billions. Yeah. The United States is a very interesting place. Let me see if there are any other questions real quick through this. Someone asked about cell theory. Kiss Killer, you asked about engineering physics. So engineering physics is like regular physics, but then they start making it more directly applied to certain situations. So for instance, there's like engineering thermodynamics, which is very different than regular like physics thermodynamics. So here, I'll show you something real quick before I go to Noise's question. So like pure physics thermodynamics uses a lot of PV, NRT. There's a lot of stat mech in it too. So there's some like probability distribution functions, there's Boltzmann's functions. It's a lot of math and like equations and whatnot. But engineering physics, engineering thermodynamics, which is an engineering physics class, looks at thermodynamics but in the practical sense. And the majority of what engineering with thermodynamics are turbines. So it's a lot of like dealing with turbines, which turbines use steam as their main like way to drive electricity. So you end up doing a lot of problems just involving water that is either heated or cooled down at various states, and figuring out how much electricity and work can like come out of it. And in order to make it quicker, what they do is they use tables. So thermodynamic here, tables. So I'll show you an example of what they are. Yeah, they use like this shit, dude. Like what? I'm just like. So instead of using calculators and stuff to run all the numbers, they have a bunch of approximations that are already pre-calculated for you, and you end up just like finding them on a table. So this is an example of one. I taught an engineering thermodynamics class at one point, and I was kind of like, yeah, here it is. They're called like, for instance, this is saturated water pressure table. So this shows for a bunch of different pressures what the saturation temperatures are, which is Tsat, what the energy is, which is internal energy, what the enthalpy is, what the entropy. These are all quantities that you could calculate exactly using physics equations and whatnot. But in the engineering world, you just need to be good enough. You just got to be close enough. And so what they do is they use these tables to kind of approximate everything. It's interesting, but I guess it's more useful in like being direct, I guess. Engineer pi equals E equals the square root of G equals 3. Yeah, pretty much. Yeah, they do that. Yeah. Yeah. Let's see. Okay. Two birds are flying towards their nest, which is in a tree relative to a fixed origin. The flight path of the model is modeled by a straight line. The equation for the flight path of the first bird is this. Okay. So this is a three-dimensional line, right? This looks like y equals mx plus b, right? Oh, I guess this is b plus mx, right? Where this is like the x. This is, for instance, our slope, and this is the coordinate, or sorry, this is Sorry, this is B. Yeah, and then this is our coordinate where we're at. The equation for the flight path of the second bird is this. Cool. Where gamma and u are scalar parameters and a is a constant. Okay, so a is a variable. This is just fancy words for like it's a number. And this is probably, for instance, the time is what it is. This looks like, for instance, distance is equal to like initial position plus t times the velocity. Right, where this is like the velocity and this is the time. Kind of cool. All right. In the model, the angle between the bird's flight is 120 degrees. Determine the value of A. Ooh, okay. I like this. Okay. So we have two flight paths, right? And we want the angle between them to be A. Okay. Well, I know. So these are vectors, right? That's why they're also bolded, right, Noise? And what I know is if I have two vectors, if I have vector A dotted with vector B, right? This is going to equal the magnitude of A times the magnitude of B times the cosine of the angle in between them. That's where this comes from. Yeah. Okay, cool. And okay. Let me think. This is where it starts. I want the angle. So if I want the angle between the trajectories, right? I think I only want the direction of I want like the slope, really, right? So I think we just deal with these. I don't think we deal with the initial position because I care about the path of like where they're going, I believe. Or okay. Wait. No. I think I know what we have to do here. Yeah, I only need the direction, right? Yeah. The other thing I could have done, I could have plugged in a value for these. I could plug in 0, I guess, or something. And maybe subtract them from each other to plug in two different values from you and then subtract them. But yeah, you're right. I would just get the slope. Okay. Okay, so I'm going to dot this with this. Okay. So that's 2 times 0 plus A times 1 times 0 times -1. Or sorry, plus here. So when you dot product vectors, you take the components, like the top one and the top one, you multiply them together, and then you add it to the next one, which is the middle one times the middle one, and then you add it to the bottom one times the bottom one. Yeah. So this ends up being whatever. This is just A. Okay, cool. So I get A is equal to, so now we need the magnitude of this. Exclusive news, Noise uses 4 for pi. Bro, that doesn't even round. No. Oh my god. Okay. Magnitude of a vector. So this is cool. This is where the Pythagorean theorem kind of comes into play. So if I ever have a vector, for instance, that's pointing somewhere in x and somewhere in y, and I want this, the magnitude, which is the hypotenuse, we know that's going to be the square root of x squared plus y squared, because it's the same thing as x squared plus y squared is equal to, or it was really a squared plus b squared is equal to whatever, z squared. Or no, we should say c. We should say c squared. If you want to add another dimension, because these are in 3 dimensions, all you have to do is just add another number. So in this case, magnitude of A is going to be equal to the square root of each of these squared. So this is going to be 2 squared plus A squared plus 0 squared. So that becomes A squared plus 4. My A looks okay. And then for the B, that's just going to be, so that's 0, so that's 1 and 1. Okay, cool. Just square root of 2. Oh, and then this has a square root on it. My bad. Okay, and then it's cosine of the angle. Oh, but we know what the angle is. Angle is 120. Well, that's cool. Okay. So, oh, this is just the answer? Well, okay, no. Determine the value of A. Oh, ew. Ew, Noise. What? This isn't a nice math thing. What? I got like the square root here, dog. What? Okay. Square both sides. A squared is equal to A squared plus 4 times 2 times cosine squared of 120 degrees. I should just know what the cosine of 120 is, sorry. So that's it's 1/2, right? So this is 1/4. Yeah, do I remember my exact trig values? Oh, this is negative though, but then we square it so that it's positive. Yeah. Yeah, it's minus 1/2, right? And then we square it. Yeah, so it's positive 1/4. Okay, cool. Okay, whatever. This goes away to 1/2. Cool. And then what? This is 1/2 A squared is equal to 2. I think so. a squared equals 4. Wow. A is equal to plus or minus 2. Yeah. Is that right, Noise? Is it plus or minus 2? I assume you've already done this one, Noise. Minus 2 only. Ooh, interesting. Why is it minus 2 only? Is this one of those I have to go back and check it? I gotta plug it back into this thing. Let me think why that is. Oh, because this is negative. Cool. And this will only get me a positive value. You're right. Has to be negative. Okay, cool. -2. Okay. Verify that according to model, there's a common point in the flight path of the two birds and find the coordinates of this common point. Okay. Well, I just got to set these equal to each other. Yeah, you're right. Yeah, cosine of 120 is negative. Okay. Okay, so we have -1, 5, 2, plus lambda 2 minus 2, 0. Has to equal at some point 4, -1, 3, plus mu 0, 1, -1. Okay, let me think. Okay, let's do some vector algebra. So I'm just going to subtract these two, right? And then I'm going to add these two. Well, yeah, I can distribute the lambda in, right? So that's -5, 6, -1. I think that's right. Yeah. And then this is... I wonder if I can distribute it. Yeah, right. I can do this, right? Yeah, plus lambda minus... I always got to remember in vectors, like, which ones you're allowed to commutate and which ones you're not. So then this is 2. Oh, wait, maybe that's not right. One sec. Oh, no, I can't do that. I wanted to do it. No, I can't factor those out. My bad. Sorry, this is 2 lambda. And then this is -2 lambda minus mu. And then this is 0 lambda. And then this is plus mu. Okay. Yeah, you're right, Norse. I can't do that. Okay. Yeah, cool. I think that's right. I have gotten better at my linear algebra. Yo, thanks to you, Noise. I appreciate that. Okay. And this all has to equal 0, 0, 0. Right? So what I did was I moved this over. So you do this minus this, this minus this, this minus this. And that gets you each of the columns here. And then I distributed this into this. I distributed this into this. And then I just subtracted it. Okay. So I have some equations here, right? So I have -5 plus 2 lambda must equal 0. I have 6 minus 2 lambda minus mu must equal 0. Oh, and this is very cool. And -1 plus mu is equal to 0. That tells me right away what mu is, right? This is cool. This is a systems of equations. So I know right off the bat that mu is equal to 1. Okay? And if mu is 1... Oh, and then I know this one, right? So this tells me from here, right, that lambda is equal to... So if I move that over and then divide by 2, that's 5/2. Okay, now we got to check to make sure that's correct, though. So let's put it back in, right? So 6 minus... So this becomes 6 minus 5 minus 1. So this is all 0. So cool, this checks. Nice. Okay. Good, it's consistent. Awesome. Okay, cool. So verify, yes. Okay, the ground... Oh, no! Now I gotta do the point to a plane. Dude, I'm so bad at this. I'm so bad at this one. I like how Noise keeps testing me on this one, though, because I always screw this one up. Okay. So we have the common point, too, right? What is the common... So the common point is plugging this stuff into one of these equations. So here, we can plug it into... Which one do I want to plug it into? Let me plug it into this one. So... Or actually, no, let me plug it in this one. This one's like super easy, right? Because mu just equals 1. Okay. So our common point... that's going to be equal to 4 0, 2, right? I think that's what it is. Yeah, okay, cool. This is the common point. And then I need a distance from that point to the plane, which has this equation. And I want to determine the shortest distance from the nest to the ground level. Okay. So I need, and then what is that equation? That's 2x minus 3y plus z is equal to 2. There is a formula. I know. What is it, though? Okay, well, whatever. I'll figure it out. Yeah. I also like showing you guys how to figure things out if you don't know things. Because I know things, but I don't know everything. And even if I did know everything, I'd forget it because there's only so much room in the brain. So distance from point to plane equation. Let's see what the equation is. Okay. Is that the shortest distance too? Who's this guy? Is this, dude? There's somewhere where it's like Bob's Math World, dude. I love Bob's Math World. Where's that guy? We first calculate an expression for the unit vector normal. Okay. Where do they have the equation here? Okay. Okay. So for this, okay, good. So we could write the equation as this, right? Yeah. Good. Ax plus by plus cz is equal d is equal to 0. And then the normal vector is this, okay? And then the distance is, the magnitude, cool, right, of the normal vector dotted with the vector of where our thing is. So, okay, here's the equation. It simplifies down to this, which is nice. And x1 must be the point, I guess. Here, let me pull that in. Okay, cool. So in this case, yeah, A is equal to 2, B is equal to -3, C is equal to 1, because those are the coefficients, right, in front of things. And then this would have been moved over, so D would equal to -2. And then we say x1 is equal to 4, y1 is equal to 0, and then z1 is equal to 2. Yeah, and then you just plug this in. So what is this? This is 8 plus 0 plus 2 minus 2, absolute value, all over the square root of 4 plus 9 plus 1. Okay, so that goes away. So it's 8 over the square root of 14. So 8 root 14 over 14, which is then 4 root 4. Well, actually, can I pull something out of 14? No, 14 is prime, isn't it? Yeah. So 4 root 14 over 7. Is that the right answer, Noise? It's kind of a cool one. Yepers. Okay, we're good. Nice. Good. Thank you, dude. Well, I mean, I only smashed it because I could look up, like, this general form, which, I don't know. I kind of like the derivation of, like, where it comes from. This would be a cool thing for me to go over at a later time, I guess. Like, where this actually, like, comes from. Because there is some very pretty math here. There's some very pretty vector, linear algebra math stuff here. Yeah. I like that there's a formula at the end, but it's better for you to understand like where the formula comes from. It kind of it makes more sense, and you're more likely to remember it. What's up, Riplaw? Okay, cool. All right, let's see. What do we got for our next question? Have fun with this one, dude. What? Excuse me, Jamarcus? What the hell is this, dude? Oh, derive the formula for the scalar product? I mean, that's pretty easy to do in 2 dimensions. It's not the hardest thing, is it? And then here, let's take this. Put that one in. Ugh, a little tired. He doesn't know the cosine rule? What, he doesn't know what trig functions are? Jamarcus should know what trig functions are. He says, my question is from interesting stuff. I agree. What is this, dude? Sorry, what? What? Explain to me what tree is. What is tree? Or maybe give me a link to it. I've never seen this. Jamarcus does like really cool like math Olympiad questions, so they're kind of like far out there. Definitely batting above his level, but it's cool to see him do these things. And I learn stuff too. Yeah, Rip, do you want me to do yours next? Because you haven't asked in a while. I'll give you priority. Oh, he doesn't know the law of cosines. Oh yeah, okay. Okay. I shall look it up. We're looking up what the tree of 3 is. Oh, the tree theorem. Kruskal's tree theorem. The set of finite trees over a well quasi-ordered set of labels. Oh, so much math jargon. Ooh. Okay. Okay. Okay, that is very complicated stuff. Yeah, is there an easier yeah. This is what happens, dude. I hate this with Wikipedia sometimes. Is like they just put too much math jargon on it. They just try to confuse you. I'm just like, what? I don't understand all these words. All right, give me a picture. Okay. Maximum. This is the video I watched. Okay, cool. Let's watch the video. Is it a short video?
From the beginning, we've
I do need to just get YouTube Premium. I know. They keep wanting me to do it. It's not short though. Oh, is there a short explanation of it? Okay. Pentation, hexation, we can create enormous numbers. Okay, wait. There's a part right here that has it. Okay.
Extremely small in comparison to the tree of 3. To explain what this number is, we need to play a game of trees.
Alright, let's
In
play a
this
game of trees.
we try to
I'm down.
create a forest using colored seeds. Follow
Seeds,
2 rows.
okay.
The nth tree can't have more than n seeds. The first tree can have only 1 seed. The
Okay.
next can have more than 2, and so on. The second
The nth tree can't have more than n seeds. Okay. Yeah, I know the volume from YouTube doesn't come through to Discord. Yeah, because otherwise your guys' volume would also come through. Yeah.
rule is that when you
Well, here, let me put the closed captioning on.
try to build a tree, it cannot contain any of the earlier trees within itself. For example, this tree contains this one, so it cannot be built. Also, the
Wait. No tree can contain any of the other earlier trees. Okay.
tree
Oh, so it has to be
contains
unique.
another tree when they preserve the nearest common ancestor rule. In this tree, the nearest common ancestor of the yellow and red seeds is the green seed.
Yes.
In the other tree, the nearest common ancestor of the yellow and red seeds is also the green seed. It means that
Oh, that's very cool. The nearest common ancestor. So the thing that they both share. Uh-huh.
the first tree is contained in the second tree.
That's
so
cool.
The second tree cannot be built. The tree of n function tells us how many trees we can build using n
Maximum
colors
color
of
of your
seeds.
tree is using n color seeds.
Using one color, we can only build one tree.
Okay.
The first tree will have 1 seed, and any further trees would contain this tree. So tree of 1 is equal to 1.
Okay.
When we have 2 colors of seeds, red and green, the first tree has 1 red seed, the next can have any red seeds because it would contain the first tree, so we can use 2 green seeds. To build the next tree, we still can't use the red seeds, we also can't use more than 2 green seeds. But the third tree can have at most 3 seeds, so it can have only 1 seed, and it can only be a green seed to not contain any of the previous trees. We can't build any more trees, so 3 of 2 is equal to 3. Using 3 colors of seeds, we start with a tree that has only 1 seed. Then we can have this tree, then another one, and all of them obey the rules of the game. And we can go on, and build more
Oh, wow.
and more trees. The total number of trees we can build using 3 colors of seeds is equal to 3 of 3. This number is massive.
Yeah, number's massive, yeah.
Abraham's number. But
Yeah,
we
what?
know that it is finite.
Oh, it is finite. Oh, that's
Abraham's
cool.
number denoted that
Okay. That's cool. Dr. Gold ASMR stream. Oh, yeah, my bad. Sorry. I don't mean to be eating in front of the mic. I should stop that. Sorry. I'm hungry. I haven't eaten all day. Yes. Okay, cool. Okay, calculate either tree of 3 or tree of Graham's number. Is this the G63? Oh, okay.
as G63 is a colossal number. But we don't have to stop at G63. We can keep going. G64 is defined as
Okay,
3
what's
followed
Graham's
by
number, though?
G63 of
Wait, that's over here.
3 is equal to 3 pentated to 3 pentated to 3. This number can't be compared to anything in the real world. With this giant number, we can start creating the Graham's number, which is one of the most famous big numbers. To construct it, we start by defining that 3 hexated to 3 is equal to G0. Hexation is denoted using only 4 arrows and already generates enormous numbers, but G1 is equal to 3 followed by G0 number of arrows and another 3. Just imagine how big this number is. Next
Oh.
we have G2, which is denoted using G1 number of arrows. G3 is equal to 3, G2 number of arrows.
What are all these arrows that are happening, though, dude? What? Okay, Jamarcus. All right. So this is a very big number. Okay. So is this basically impossible? Because we did say this was actually finite, though, right? We said that tree 3 was. I still can't move my arms because of the gym. Good. I'm glad you went to the gym. I need to go to the gym. Yes. Okay. Cool. Let's see if there's a proof for this. I'm actually curious. How can you prove tree is tree 3 finite? Okay. However, the amount of time it would take to prove the finiteness of tree 3 is so large that the universe will come to an end before concluding the proof. What? Oh, Jamarcus, what is this question, dude? It's a 16-page long proof. Okay, let's see. I want to see it. Oh, here we go. Here we go. Someone's done it. Okay. Here's your answer, Jamarcus. Which I don't think I can go over on the stream. But this is cool. Actually, this is good to learn. Have you ever done this, Jamarcus? Have you ever looked at math proofs, like papers and whatnot? They involve things like lemmas, right? And then you have statements. Too confusing for me. Okay. I think this is something that would be cool to go through at some point. It's weird math stuff. Yeah, I agree it's weird math stuff. Symbols. Yeah, because then you got these, right? Like, and then you have words like epimorphism, homomorphism. Yeah, monomorphism. This is Hypatia land, is what this is. So Hypatia is one of our more advanced maths fellows, and they teach They teach math at the college level, and I think goes into funny words, magic runes. Yeah, exactly. Yeah, look, dude. There's even this is the natural sign from music. This is how you know things are starting to get weird. Is when math starts like using random symbols from other things. That's a music thing to have that. Yeah, look at this. What? Yeah, right? I don't know if any of you guys like read music, but you know, music notes sample. Yeah. Yeah, like here. Do you see how that same symbol comes up? Yeah. Why is music stuff in there? It's just because they run out of symbols, dude. Like, math starts going so hard that they start running out of symbols, so they start using symbols from other things. That's when you know you're doing math. Yeah, exactly, dude. I agree. Yeah. Okay. Well, here, I'm going to post this link. If you want to try going through this at some point, that's a good explanation for where it comes from. I don't know how to prove it. Did you actually want me to solve? I don't think I can. That's a 16-page math proof. If I'm being honest, no. Oh, you don't want to go through it? I think it'd be cool for you to learn, though. Okay. All good. I'm still going to count it as a question. So, you're good. The days when the biggest number was 100, right? Those are good days. All right, where's OP? Let's get OP up here. Well, not OP, sorry. It was Riplaw, sorry. Riplaw was the other one. Not Rip Marshall. You guys all have Rip in your names. Riplaw. What's up, Rip? Okay, nice. Good. Okay. All right. Yeah, let's do your question here. I like this one. A contractor is building the base of a circular fountain. On the blueprint, the base of the fountain has a diameter of 18 centimeters. The blueprint has a scale of 3 centimeters to 4 feet. This is cool. Scales. So yeah, so we know that 3 centimeters is equal to 4 feet. Okay. What will be the actual area of the base of the fountain in square feet after it's built? Round your answer to the nearest tenth of a foot. Oh, you have to go, Jamarcus? It's okay. Come back after dinner. I hate that class. This is fun, dude. I love designing and modeling things, man. Yeah. Okay. Yeah, what this is basically saying, this stuff is bad. I used to do this all the time with my dad. My dad used to buy these models and stuff, and used to build them, and they would have a scale factor. I think I've gone over this before, like what a scale is. So this is saying, for instance, that like every 3 centimeters on this piece of paper corresponds to 4 feet in real life. Okay. Because if you had blueprints for something, right, it can't be the actual size. The blueprints would be massive. Here's what like some example like blueprints look like. Here, I'll show you guys. Yeah, they end up looking something like this. These are like what blueprints are. So, when they used to build buildings and stuff, before they had computers and CAD and modeling and whatnot, they used to have like all these, and they're called blueprints because they were done on blue paper. I wonder why they were done on blue paper. No, Teacup, I'm gonna do yours. I'm just doing OPs real quick, or Riplaw's real quick because he hasn't done one in a bit. Yeah, blueprints are cool. Here, let me see if there's like a stock photo of like people. Blueprints, real, stop, people. Yeah, it's something like this. They're just people just going through, and they're like, oh, that's where we're gonna put the fountain. Yes. Nowadays, they probably just use iPads. But back in the day, this is how they used to know where to put things when they were building stuff. Okay. All right. We love scalars. Okay. Okay, Riplaw. They want us to figure out what the actual area of the base of the fountain is. Okay. How do you know how to figure out the area of the base of the fountain? Do you know? We make a table. We can't make a table. But let's come up with an equation first, right? So, we know that the fountain has a circular base, right? So, what's going to be the equation for the area of that circular base? No, it's okay. Yeah, I'm sure you learned it one way, but, you know, let me help you understand it, like, completely. Okay. Yeah. So, what's the area equal to? What would that be equal to, Riplaw? You know, it's a circular fountain. right? So you need to remember what the area of a circle is. What's the area of a circle? You're not sure? That's okay. So the area of a circle is equal to pi times r squared. This is the radius squared is what we say. Okay. So if you have a circle. Yeah, I'm sure you've seen that before, right? Circle. Radius, right? Okay. Okay. So we need to figure out the radius, right? So what they tell us is that the fountain on the blueprint has a diameter of 18 centimeters. Okay. So if on the blueprint the diameter is 18 centimeters, what is the radius going to be on the blueprint? This is where you have to remember the relationship between diameter and radius, right? Let's say this is the diameter. I think it's going to be 9. Good. Yes. Yes. Because the thing we learn is that the diameter, right, is equal to 2 times the radius. So if this is 18, that means the radius must be 9. Yeah, radius is always just half of the diameter. Good. Okay. So, I know that on the blueprint, the radius is equal to 9 centimeters. Okay. But in real life, right, that's got to be something different. And what we know is that every 3 centimeters on the blueprint is 4 feet, we would say, like, in real life, IRL. So, if on my blueprint I have something that is 9 centimeters, how big is it in real life? This is where you may need to do some tabling stuff or whatnot. I'm curious, what does your teacher mean by tabling stuff? Can you repeat what you said? That's okay. All right. If on the blueprint, Riplaw, if it's 9 centimeters on the blueprint, how many feet is it in real life? What they tell us here, Rip, is that on the scale here, right? The scale says that for every 3 centimeters on the blueprint, it's 4 feet in real life. So if it's 9 centimeters, how many feet is it going to be? Yeah, exactly. Conversion ratios, yeah. Yeah, this is like the ratio thing, right? Okay. So we know 3 centimeters is the same thing as 4 feet, right? So this must be equal to, 9 centimeters is equal to how many feet, right? This is called common ratios, right? I know every 3 centimeter corresponds to 4 feet. So 9 centimeters must correspond to how much feet? Good, 12. Yeah. And the way we got that, a couple ways you can do that. So this is a nice number, 9. You can obviously see that, right? That 9 centimeters is just 3 of these, right? Because 3 centimeters will go into 9 3 times. So if I have 3 of these things, I have 3 of these things, and 3 times 4 is 12. If this wasn't a nice number, and you had to, like, not do this in your head, this is the way to do it. And you can do this kind of by, like, again, cross. I think you guys call this, like, the butterfly method or something, right? But you cross multiply. And so this is 9 times 4, which equals 36. And then this needs to also equal, right? This thing, 3 times whatever. We'll say like 3 times x, right? Let's say this is x. And then you just divide both sides by 3. And so you get x equal to 12. Okay, good. Yes. So on the blueprint, it's 9 centimeters. So we say IRL r is equal to 12 feet. You got to be careful with the units here, because this is like centimeters and feet. Okay? What do we do next? Last step. You got it. Last step. I know you do. Easy, easy. We multiply with pi. Good. But, okay, first, we got to square it, though, right? So this is pi times 12 squared. Right? Do you see how there was an r squared? Pi r squared? Yes, okay. So what does that end up being? What's 12 squared? You should know this one. This isn't that bad of a one. It's the same refresh rate these nice gaming monitors have. So 12 squared is going to be 144. So this is 144 pi. And then it's very important here. You got to put the units. Rip law. So they tell you they tell you here, right? They say square foot. So this is going to be 144 pi square feet, which they are telling you also to round this to the nearest tenth. So this is where technically you probably want to, use your calculator. So we use a calculator. 144 times pi. That's going to give us 452.38. So to the nearest tenths, that's 452.4. Okay. So we're going to say this is 452.4. And then you can say this. You can say feet squared. That's the correct answer. And there you go. Yeah. There is an easier way to get it? Oh, tell me. Tell me, OP. Rip. Sorry, what was the easiest way? I mean, there may be an easier trick, but I like to teach you guys, like, the general way to do it. It's pi times 12 to the second power. Yeah, that's what we did. That's what this was, right? For me, it gave the 452. Yeah, but there should have been a decimal on it, right? So if you look on the calculator here. Also, this uses the exact version of pi. I guess if you use just 3.14, now it's like 452.2, If you're, a savage like Noise and you use 3, then that gets you 432, right? You see how these are just like different numbers? Yeah. It's all about just approximating pi. Because pi is like technically, all these one things. 3.14159. I think I know up to here. I know the 14159, and then I forget the 2654. But, yeah. Yeah, you want to impress someone, tell them how many digits of pi you know. Can I get a picture of this? Yeah, sure you can. Yeah, here. So what I'll do is I'll save it. I'll download it as a JPEG for you. And then once we have it, here, I'll throw it in the chat for you. There you go. There you go. There's a picture. Yes. You're very welcome. Yeah, always come by. Ask me these questions. I got you, dude. Who has Faraday's Law? Who's the Faraday's Law question? Who was that? Oh, it was you, Teacup. Oh, Teacup, come on. Come on up, Teacup. What's up, Teacup? Our new gilded game master, Teacup. Is your mic working, Teacup? Mr. Bean gonna come out? I like Mr. Bean coming out. Yes, he's here. Okay, cool.
Yeah.
Well, you did get skipped just because Ripple hasn't asked a question in a while, and I know last time that he tried to ask a question that I went too late, and then he wasn't able to be awake for it. So You know?
Oh, that makes more sense.
Yeah, sometimes I got to make sure that, you know, if someone gets skipped, I got to make sure I ask them a question later. Dr. Gold uses JPEG because he doesn't think Riplaw is worth that beautiful PNG lossless compression. 0 out of 10. I just worry that if he downloads the file as a PNG, it may do something weird on his phone. JPEG, I know, will work. For some reason, like PNGs on certain phones, they can't handle the transparency layer, and it just ends up looking weird. So I know JPEG will work. That's why I did it. Yes, I know about the differences in image compression. I should have given it to him as a vector file or a PDF, right? Yeah. Okay. Teacup. Faraday's law. This is cool. Calculate dv. Ooh, this is good. Okay, I like this. Okay, so now we're doing derivatives with a bunch of different variables. Okay. Uh-huh. Okay. All right. And this is actually a physics thing, too. Faraday's law. It has to do with... This is how railguns work, for instance. You guys seen, like, the military...
Oh,
when
I
they...
love railgun.
Yeah, railguns. Railguns work by Faraday's law. It's pretty cool. It's like Faraday's law in reverse. If you run a current through something, you get a changing magnetic flux. BMP master race. Stop it, noise. Okay. Yes. Okay. So we say that, yes, the voltage here is equal to negative BL times little v. Okay. So actually, let me make this like a... I'm gonna call this big V, right? Is equal to negative... I hate when variables are the same thing. I'm just like, man, okay. And they want us to calculate d big V dv. Okay. Do you know how to do this?
So they want derivative of v and derivative of v.
Yes, I know. It's a shitty choice of letters. They want the derivative of this with respect to v. Okay. So let me give a little bit of a little context here. So if you have, for instance, y is equal to 5x squared, right? What's the derivative of this?
Y equals 5x squared would be 10x is 10x.
Just 10x. 10x the first, yeah. So, yeah. You know that y prime, right? That's the derivative. That's equal to just 10x. Really what happened here as well, Teacup, is this is the same thing as saying dy dx is equal to 10x. Because what you did is you took the derivative of y, which is this thing, with respect to x. Okay? What that means is you only care about how y is changing, y is this whole thing, with respect to the x variable. Okay? That's why, for instance, if this was 5x squared, right, plus, let's say, like, 6z, okay? dy dx would still be equal to 10x. Because I don't care...
You care about x.
I don't care about z. I don't care about z, because I only care about things with x. Where this changes, though, is if z depends on x, then you do have to consider what happens to z. Okay? So let's say z was equal to like x squared plus 2, right? Or so, or I don't know, like I don't know, or x to the 6th or something.
Do we need the derivative of v now?
Exactly. So what you would need to do is you would do the derivative with respect to z, and then you would do the derivative of z with respect to x. This is also called the chain rule, is what this is. So what you would do is you would do dy dz times dz dx. Do you see how these cancel out? Do you see how the dz's cancel? This is actually a pretty cool thing with the chain rule. Do you see how dz is on the bottom and dz is on the top here? And these cancel out, and you just get dy over dx? Yeah, this is why we say, like, okay, dy dx. Okay, because if I took the derivative of 6z with respect to z, what would that derivative be?
Okay, so we have dy dz times d. Wait, hold on.
Yeah, just do dy dz of 6z. What would that be?
Okay, dy dz of dz. So you want the derivative of 6z.
Yeah.
And that would just be 0, like 0. It would be 0 That would be 1 times 6 to the
Yes.
0 power.
1 times 6 times z to the 0, right?
Yes.
Okay. Do you see how yeah, this is just 6, right? So that's what this is, right? Okay. That's dy dz. Okay. But then I need dz dx, okay? What did we say z was?
We said z was x to the 6.
So what's the derivative of this with respect to x now?
Okay, so we want. Do we want the derivative of x?
Well, we want the derivative of z with respect to x. So you're just treating x as the thing that you take derivatives with respect to.
Okay, so it'd be 5x to the 5th.
Good. 5x
That'll
to the
be
5th.
6x
Good.
to the 5th.
Oh, sorry, 6x to the 5th. Yeah, sorry. Yeah, you're right. Yeah. Okay, good. Yes. So see how this now becomes this? Okay. So what we end up getting, right, is 6 times 6x to the 5th. That's equal to 36x to the 5th. Okay? Look what would have happened, Teacup, if I just, like, plugged this in just straight away, right? Let's say I just had 6x to the 6th, right? What's that derivative with respect to x?
What is that? 36 to the 5th?
36x to the 5th, yeah. Do you see how this is the same thing?
Yes.
Good, okay. That's the chain rule.
I'm sure we wasted a bunch of time.
Yeah. No, this is important. This is important to know this, okay? So, when we're doing this one, okay, d capital V with respect to V, right? I want to know, right, what the derivative of this thing is, right, with respect to only the V. And I'm only allowed to do that so long as this does not depend on V and this does not depend on V.
Whoa.
We know, and little v here is the velocity, okay?
But b equals 2 and t equals 0.5.
Good, right. You see how these don't change? They don't change, right? They're just constants.
Yeah.
Right. So you don't need to worry about these. Okay. So then what is this derivative going to be with respect to v?
Then that just be v to the 0.
Good. This is, right? So this becomes 1 times v to the 0. But this stuff is still here, right?
That would be 2.5.
So it's just negative BL. No, it's 2 times 0.5.
I swear that says t there.
Where? Where do you see t?
Oh wait, no, I said that. Okay, I'm blind. My bad.
This is L. This is an L. Yeah. Yeah, good. So yeah, that went away, right? Because these are just numbers, right? It's like the derivative of 5x is just 5, right? You can get rid of this thing.
Yes.
Okay. So this just ends up being equal to 1, right?
We did it.
Good. Good. Okay.
Now I need to.
Find the rate of change of v with respect to t if v is this. Ah.
So now it relies on it.
So now this is good. This is why it was good we did the chain rule, because now they want dv dt dt,
and
right?
DT, and then it would be what, dt over dv.
Dv over dt. So this is equal to, right, dv. Yeah, this is why we did the chain rule. Over d little v times dv.
dv over
Good. Right? Do you see how these are going to go away, right? Eventually. We figured out what this was, right? What was this?
we figured out that dv was 1. Well,
Good.
d.
Okay. So now we just have to figure out this, dv dt. Where this is little
We
v.
know that that's just 1 over 4x plus 9, obviously. Obviously.
Yeah. So yeah, v is equal to 4. Noise says, why is negative BL equal to 1? Because B is 2 and L is 0.5. Sorry, they give that right here, Noise. I don't know if you can read that. So B times L is just 2 times 0.5. Okay. So V is equal to 4t plus 9, right? So what's the derivative of that with respect to t?
Okay, so it's
Yeah, I know it's tiny.
t. So we need to do the derivative of t.
The derivative of this with respect to t. So that means I'm only looking at t's as my things that I do derivatives of.
That
Right.
would just be t. That would just be t to the 0.
Mm-hmm. So what does it become?
T to the 0. V equals 4 plus 9.
No, but what's the derivative of 9?
Right. Oh, derivative of 9. Oh, damn. I don't know what the derivative of 9 is.
Well, what's the derivative
9
of just
to
a
the
number?
0. 9 to the 0.
No. Well, so this is like 9 times t to the 0. See how that comes down? T to the 0 is the same thing as 1. 9 is a constant. 9 doesn't depend on t, right? The derivative of something that doesn't depend on the thing you're taking the derivative with respect to, that just goes to 0 always. Okay? Does that make sense to you, Kat?
No.
Okay. How much does 9 change by... Yeah, I like this. Kiss Killer. Yeah. How much does 9 change by every time t changes?
Well, it's a constant, so why would it change?
It doesn't change. Yeah, good. So the derivative of it is 0. It doesn't change, right?
Yes.
That's why the derivative of constants are 0. Okay. Yeah, this goes away. Okay. So you're just left with 4t, right?
And yeah.
Okay. So then what's your answer? Yeah, that's why. You're good, dude.
We can cancel out dv.
No. You figured out that this whole thing was 1, and you figured out this whole thing was 4t.
Oh, so that's just 1 times 4t.
That's good. 4t. Congrats. Good job.
Clearly it would be 4,296, 4,292 cubed, 13th power
Yeah.
to 290.
This is a good, it's cool. This actually blends into a little bit of physics. So here, let me show you the physics behind this, actually. This is actually pretty cool. Yeah. No, you did a good job there. It's good question, Ethan. Not Ethan, sorry. I'm mixing up everybody's names today. Ugh. I'm so sorry. It was kind of a long weekend. I went to bed at 9 o'clock in the morning from Saturday night. So it was kind of late. But worth it. I think it's 4, not 4t. Oh, thank you. Yeah, I probably screwed up. Sorry. Yeah, that is my brain just messing up. Yeah, you're so right, dude. Yeah, thank you, dude. Yeah, it's not 4t, it's just 4. Thank you. Exeventian. Yeah, no, that was my screw up, yeah. Yeah, derivative of 4t is just equal to 4. Yeah, sorry. Yeah, you're right. Yeah, let me show you. You're way more interested in the physics? Yeah, let me show the physics of this. It's actually pretty cool. This is called Faraday's Law, but one sec. Thank you, Faraday's Law, moving rod, picture. I don't want to have to draw the picture. Here we go. This is kind of cool. Okay, there we go. And then where is the... I want a pretty thing of the picture. That's what I want. Cool. All right. So, in physics, this is an E&M topic is what this is. There was a convention called Open Sauce. You should have gone. I don't know how much time it takes you, though. Open Sauce? Oh, it was a convention. Oh, wait. Well, here, let me look. One sec. The integral form does look juicy, yes. Oh, it's in San Francisco. Oh, that's cool. Yeah, I should go to this. There's also, there's TwitchCon, right? I'm at a wedding this weekend that this is happening. I should have gone to this one, too. It's okay. All right. Yeah, the integral form is nice, but it's okay. I can do that one later. Okay. EMF, which is called electromotive force. This is the same thing as voltage. Okay. The picture I always like to show voltage, current, amps. Dude, there's an anime form of this one. Where is it? Yeah, that's it. I know you like this one. All you guys like anime for some reason, so whatever. I'll show it. Oh, it's a big image apparently. Okay. Someone rendered this. Jesus, like who rendered this in such high definition? Okay, whatever. Stop. Electricity explained. Yes, okay. So, voltage is like the pushing force in electricity. Amps, which this is like the current. This is like how much electricity is being pushed. And then ohms, which is resistance. This is what causes the current to not be pushed through as quickly. It's like the friction. It's like electric friction is kind of what we think about it. Yeah. So, you can have a voltage in a loop of wire if there is a changing magnetic flux. This is called delta, and then this is here. Let me just say this. This is equal to magnetic flux, which is equal. This is what you probably saw, noise. This is equal to the integral of B dot dA. Okay, the real way of like saying this is if you have an area. Okay, let's say this is like some area, right? Then dA is technically a vector, and dA is what we call like the surface area element. And that always points perpendicular to your surface. So this is dA, for instance. And then B would be whatever the magnetic field is. So let's say this is like B, okay? So, and the reason why it's a dot product and the reason why it's integrated is because you have to add up all of the amount of magnetic field that is parallel to the surface area vector. So it's parallel to the normal vector of your surface area. Is what it is. Yes. Magnetic flux. No. How strong the magnet is, that is B. That's the magnetic field. And that's measured in Teslas, is what this is. This is measured in Teslas. And so that's the strength of a magnetic field. And then the magnetic flux is the amount of magnetic field going perpendicular through a surface, is what it is. So in the case of, let's say, for instance, I have a surface like this, but my B field is running this way, this would have no magnetic flux because all of the magnetic field is like not running in or out of the perpendicular to the surface. They also do this, for instance, with like cubes and stuff. So let's do flux of a cube. This is a good thing. They sometimes like draw this picture. I hate that this is gonna be a bad image. Okay, here we go. Yeah. So in this case, the net magnetic flux through this thing is 0 because you have the same amount of magnetic field going into the surface that is coming out of it. So we say the net amount of flux is 0. Because this would, for instance, be negative flux, and this would be positive flux. Here, maybe I can like show like yeah. Let me put a diagram of this. Yeah, this is kind of cool. So, in this case, so let's say that this is the B field. Oh wow, that is very bad. Let's say this is the B field. Then this arrow right here, this would be, for instance, dA. This would be dA, and then this would be dA. Does that make sense, Noise? Like where the dA vectors come from? It's a way to express like where area is. So in this case, B and dA point opposite to each other. So this ends up being negative flux is what we say. And then here, right, it's the same magnetic field going just all the way through. This B dot dA would give me then positive flux. And then because one's positive and one's negative, and if they're the same shape and the same amount of magnetic field, then they cancel out, so this would have no net magnetic flux. There's no magnetic flux through this surface, right? Because B points this way, but dA points this way, so they're perpendicular, these two vectors. And what I say is that it's because B is parallel to the surface. B needs to be perpendicular to the surface. Otherwise, you take like the component of it. That's where the dot product comes in. But okay, in the case of something which is a nice geometry here, right? As such, this means into the page, the crosshair. So you can kind of think of this as like going into the page, and it's going straight in. And so there's a magnetic field, and then dA is going to be the area. And then since the magnetic field is constant everywhere, and it's pointing in the same direction, instead of integrating, I can just say that this is B times the area. So, where are my things wrong? Is equal to B times the area. Because it's perpendicular everywhere. The magnetic field is constant everywhere. Constants you can pull out of integrals. And dA is also constant everywhere, right? Okay. Okay. So, what we have here is they're saying that, for instance, this is how a railgun works. This is how a railgun works. So you have this loop of wire here, and this part of the loop is allowed to move. It's on a rail. Think of these as like, these are the rails, and then this is something that we're allowed to like move back and forth. Here, can I take this? Yeah, like this. So this like slides. It slides on the rail. Okay. Notice what happens though, right? As this thing moves, right, we end up enclosing a different amount of area in our loop, right? So let's say this thing is over here, right? Do you see how this is now the amount of area I enclose? But if the rail were here, for instance, that this would be the amount of area that I enclose? So what happens is, as this thing moves, so does the amount of area of magnetic field that's enclosed. And if we remember that magnetic field times the area is flux, that means that the amount of magnetic flux will change as this movable part of the rail moves. Okay. So, if I want to calculate, for instance, how much current or whatever there is for this to do, let's say that this, for instance, we're going to call is equal to x. This is the distance x. And we know this, right? This is what we're just going to call the width. All right, let's just call this the width. So if I want to calculate my electric flux, right? That's going to be equal, if this was a rectangle, right? This is just W times X, okay? Which is our area, times B, which is our B field, okay? So this right here is the area, and this is the B field, okay? Now, if either one of these things change, right? So if the area changes or the magnetic field changes, then the flux will change, okay? And so if we wanted to figure out how much the flux is changing, so let's say that's d phi dt, right? That's going to be equal to d dt of this, wxb. So either the width is changing, the length of it, the x position is changing, or the magnetic field is changing. Let's assume that we want this thing, we want this part of the rail to be changing. We want it to move, okay? What that does is that causes there to be a dx dt, right? The velocity at which this thing moves, this v, that's dx dt. So what I can do is I can say, okay, the width is going to be a constant, so I can pull that out. The magnetic field is a constant, right? So that just becomes wb dx dt. And then dx dt is the velocity at which the rail travels. So then this just becomes wbv. And this change in magnetic flux is also equal to the voltage. So that's where we get this, where this is equal to this big capital V we had in Teacup's last problem, which was right here. They use BLV. Okay, whatever. I used BWV. I used W instead of length. Width instead of length. It's okay. It's a rectangle. So this tells me, right, if I apply a certain amount of voltage, then this rail will move with a certain amount of velocity. And this is what railguns do in the military and whatnot, is they have this same setup and they just dump a ton of voltage into this loop, and it will cause this part of the rail to move with a really, really fast speed, which can then basically accelerate missiles, projectiles, whatever you want, really, really, really quick. Yeah. It's pretty cool. Here, we probably have a railgun. Yeah. It's a lot of power, so you need like a nuclear generator basically to get that amount of power. Oh my god, these ads. Yeah, they call it Hypervelocity Project. Yeah. I think one of the main problems faced was finding something strong enough to shoot at without killing a few people a few miles away. Yeah, these things are super cool, man. Oh, Titan needs a question? I got you, dude. Yeah. Oh, jeez, this thing just goes through so many, like, things of, like, steel plates. But yeah, that's it. That's the projectile. It's just going through everything, probably. But it works on the same... It's a physics concept. They just have a rail. They dump a lot of electricity in it, and it causes the rail to move really quickly, and that launches projectiles really quick. Oh, yeah, you're welcome for the explanation. Yeah. Yeah, Faraday's law is super cool. It's how, like, motors and everything work. They're really dope. I love E&M. E&M is, like, my favorite part of physics. That's why I got involved in plasma physics, is because I loved E&M. Yeah. Okay. What's up, Titan? Titan's got a question. I'm getting tired. Let's see. All right. Solve and check, he says. All right, let's see. My teacher talks about it in class, but I don't understand it. All right, Titan. How do you think you do this one? This is algebra. Algebra's pretty cool. Gold, I got prestige 2. Cool. Did you ask a question? Gotta ask a question. Send me a screenshot. Combine? Yeah. How are we gonna combine? You'll do it later? Okay. How do I combine the 7x and the 5x? What do we do? Linear algebra? This is, like, I mean, technically it's linear algebra. Add? Okay. Well, they're on different sides of the equal sign. Do you see this, Titan? Do you see how this is, like, on this side of the equal sign? This one's over here. Yeah. So if I want to combine these two things, I need to move one to the other, okay? The way to move it, right, is to sorry, is to subtract one of them. Okay? So I think what you want to do is you want to do minus 5x minus 5. Okay, we'll see if you got it. Okay. So 2x minus 3 is equal to 5. What do you do next? Yeah, good. Add 3. So then you get 2x is equal to 8. Last step. Divided. Yeah, divide by 2. You get x is equal to 4. That's technically correct. But then they say check it. So this is always a good thing you should do on your math tests. You should always check the numbers. It's just easy. So what you want to do here, Titan, is you just want to plug 4 back in and just see what happens. So if I do 7 times 4 minus 3 is equal to 5 times 4 plus 5. You see how I just plugged 4 back in for x? Yeah? Okay, cool. This becomes 28 minus 3, which is 25. This becomes 20 plus 5, which is 25, which is good. All checks out, and you're done. Yeah, you're good, Titan. Easy, GG, easy. Yeah, doesn't matter how easy or hard your question is. I'm, you know, just ask it here. That's why it's here. If you're just like, oh, I just didn't get this a little bit, then you're good. What's up, Grim?
What's up?
What's up?
What's up?
What's up?
What's up?
Are you off of work?
Wash your hands?
Are you off of work? You done with work? Wednesday?
I don't work today.
Oh, you don't work
tomorrow.
Today? Okay, that's cool.
Wednesday I don't have work, thankfully. And Thursday I'm gonna go to the mall and buy some new clothes.
Where are you gonna get your clothes from?
The mall.
All right, night noise. Well, what store? What store?
I don't know what store. Yeah, I'm gonna let April choose.
Oh, she like your girl? Your girly? Your new waifu?
Friend.
You got a new waifu?
Friend.
Friend.
I'm not Nick. I'll never say that again. Hey.
Dude, what's wrong with waifu? I kind of like that word, waifu.
The waifu relates to an anime person that you wish was your wife, but also could relate to it.
Oh, but like isn't real?
Like, yeah, like it isn't a real thing. It's just your delusions.
Oh yeah, we don't like that, dude.
Yeah,
Y'all should date real people.
I'm just gonna go to the mall and spend $1,000 on clothes.
Well, don't do that. Don't you need to save for a car?
I already have a car.
Oh, well, that's dope. Okay.
I got it yesterday night.
Well, yeah, treat yourself. Yeah, go get some clothes. I guess that's fun. Send me some pictures of like what style you're looking at, dude. I want to know what the kids are like. You know, what are they rocking these days?
Like actually, the other day I was asking what style should go to April, and she's like streetwear, and I'm like, the fuck is that?
Streetwear is like you know, like Supreme and stuff. Do you guys know what streetwear is? I'm sure, right?
Yeah.
I don't know. Some
Yeah,
of it's kind of like trash, honestly. Streetwear fashion.
Yeah.
Yeah, it's like all this stuff.
Nick
I
wants
don't
to join.
know.
Should I let him join?
Yeah,
Should
you
I let
can-
him up here?
Yeah, what's up, Nick? You can come up. What's up, dog? Yeah, I don't know. Streetwear is like all right.
I'm too gold. It is your life to go. Come on.
Wait, what's up? What's up?
It's his waifu.
But okay, apparently waifu means someone that you can't actually get though, is what he's saying.
Yeah.
Yeah, it's
He's,
anime.
he's saying it's like not real.
Yeah.
No, I said, one. I said one. If it's anime and it's not real, then boom. And then I said two, like someone online that you like wish was yours, but like it can't actually happen.
Oh, I
It's like
see.
a Discord.
So a
Discord,
delusion.
Something different.
It's
Not
like
waifu.
it's like you're like coveting. You're like jealous, like something you can't have. Okay.
Mm.
Okay. I mean, it's all right to have dreams and stuff. You know, just make your
It's all right
dreams
to-
make your dreams a reality, dude.
But, yeah,
go do it.
If y'all want to put together, then like y'all should just like you should move on and find someone better.
I agree.
Yeah,
Yeah,
what if
don't.
you're my reality?
Wow. Well, that's called a one-way street, dude. Like don't be involved in like one-way streets, dude. I used to always joke that like love is a one-way street. Just because it's so hard to get anyone to admit their
It
feelings
is
these days.
sort of.
It is,
Bruh.
man. Yeah, bruh.
I usually don't admit my feelings to people.
Mm.
It's okay.
For
You're
real.
young, dude. You're young. You learn to protect yourself.
It's not bad. Like it's just I get nervous very easily, and I don't like. Whenever I get with a girl, it's
Sure.
usually be like her at first.
You
So,
don't
I
like her
was
at
just-
first, or you do like her at first?
I didn't like her at first. I was just like just learning to like play around, and that's where
Okay.
the confidence came. But if
Good.
it's someone I know and I like them, like shit, I'm not gonna be able to do shit because like
Yeah.
I know them and I'm scared about like the consequences after.
I see. Yeah, no, this is a very common thing in like in dating and whatnot. Yeah, you can't get like stuck in your head and put people. They say putting people on a pedestal, where you're like, oh, this person is like super unattainable. And you get all nervous. And I still do it, man, dude. Like the other week or something, there was this girl who's like, she's gorgeous, and I was like, oh, I should text her. And dude, I spent like hours trying to figure out like what to text her. And
Yeah.
it's so dumb, dude. You just get stuck in your head. Whereas like this weekend, dude, I like barely said like 2 sentences to this chick. I was like, I don't know. And then ended up having like the best time with her because I was just not stuck in my head like trying to come up with the perfect response. Just, I know. Don't worry. I still even deal with it, man, dude. It's a thing.
Yeah.
Just be yourself. You
And
have
we'll
to.
say we don't have feelings.
Dude, guys, no,
Yeah.
girls do not say that. No.
They do.
No, that's what
Mhm.
society says. Society says guys don't have
Yeah.
feelings, but that's wrong. That's wrong. No, you guys definitely have
Mhm.
feelings. Yeah, it's you know, it's kind of, you know, it's also a really good thing. Don't ever be concerned with the outcome. So a lot of times when guys always mess up, especially like when trying to date girls, when they focus too much on the outcome, when they're like, oh,
Yeah.
I have to kiss her, or oh, she has to come home with me, blah blah blah. If you focus too much
Yeah.
on that, then you get lost in the, enjoying the present moment. If you're just having fun in the present moment and focusing on like doing fun stuff in the now, the outcomes will happen. If you focus on the outcomes, you'll never get to them, because girls can also tell when you're like very focused on an outcome, and they're like, oh, this is kind of weird and creepy, like, why does he keep trying to like drag me back to his apartment? Like, no. Like, go have some fun somewhere else, and then like if she likes you, maybe it'll happen. Yeah.
I never try getting people to my
If it
house.
won't happen, make it happen.
No, dude, no. Consent, please. At least you got the number. Let's go. Yeah, I don't know. Numbers is a good thing, but especially in LA, dude, numbers really don't mean shit. Like, I could have a girl's number, and there's a 5% chance she texts me back. It's better than 0.
Yeah.
Kisker says, can she solve the area under a curve, though? Yeah, that is a big thing for me. I really do value intelligence, honestly. It really is. It's kind of a deal breaker for me. Is like, if I, and it doesn't have to be mathematical intelligence. It's like, can I have interesting intellectual conversations with you, as opposed to, oh, dude, what was this, dude? Someone sent me this meme. It was too funny, dude. I love this meme. One sec, let me find it. I think it's on my Facebook.
Ooh, let's look at your Facebook.
No, yeah, let's look at his Facebook, dude. Here, I probably have in Google Photos somewhere.
Bro, someone has future in my class.
There was a video about how a guy is saying that in a relationship,
Give me a second,
a
Graham.
guy
Graham, give me a
a
second.
girl,
Okay.
In a what? In a relationship,
guy-
what?
a guy treats a girl like it's his daughter.
What are you talking to?
That's kind of weird, dude. What? Excuse me?
No, not like that. I mean,
What? What are you saying, Nick?
I've had Nick on mute for months.
Grim's
That's
not letting me
crazy.
speak, yo.
All right, Graham, let him speak. What's up?
So a guy treats a girl like his daughter, like he protects her, he
Yes.
he cares for her, everything like that.
Yes.
A girl treats a guy like a father.
Yes. I agree. Well, in terms of the whole protective nature, I mean, that's how it used to be, I guess. It's a little bit different now these days, but yeah, that's...
So when a guy and a girl breaks up,
Sure.
it's harder for the guy because he treated her like a daughter.
Sure.
Because it's hard to lose a daughter.
Yes.
But we're programmed to.
We're programmed to lose our
parents.
dads? Oh, wow.
Yeah, not dads,
Oh,
but like parents.
Yeah, I mean, it kind of sucks to
So
lose your...
it's easier that way.
I think there's also, okay, if you really want to go back to like the really, really old biology stuff, in general, at least in human populations, right, if you go back to caveman times and whatnot, the men were usually the ones going out and fighting the mammoths, the tigers and whatnot, and so they were usually putting themselves in dangerous situations that they died very often, right? And for this reason, the opposite sex has to be biologically conditioned to not get too upset if that happens, because it did happen a lot. Like, dudes died a ton because they were putting themselves in really dangerous situations to do things. So yeah, as to why guys don't deal well with losing girls, I don't know where that comes from per se. I mean, maybe it's just it's all a relative thing, you know. Some of this comes down to, I don't know. As with anything, take these biology arguments kind of with like a grain of salt, though. Like, don't use them as excuses for like why things are, or like, you know, it's very easy to fall into that trap, to like kind of slip into, oh, I'm just going to use these things to justify why like I hate women or something, which is wrong. Like, don't do that. That's what Andrew Tate does. Andrew Tate tries to use these like sound biological arguments, which I agree with the arguments at least, but I don't agree with the conclusions. The conclusions tend to just fit a narrative that I think is toxic and honestly is not helping the world. It just creates...
What he says is true.
Yes, again, what he says, the stuff backed by biology, evolution, and science is true, but the conclusions he's coming up with, where he's like, women should make you a sandwich and be subservient, that's wrong. Like, no, that's what I get kind of, that's where I draw the line. I draw the line at, are we helping, trying to keep these two genders together, or, sorry, two sexes, sorry, genders are social construct, but I know, but whatever. Are we trying to have men and women still like each other, or are we trying to create more of a divide because that gets more clicks? Because Andrew Tate makes more money if people click his shit more times at the expense of two genders hating each other. I think it's wrong.
Yeah.
I don't like it. Use everything with a grain of salt.
Me personally though, like if I were to have a girl, I would want her to, and I were to have the job.
Yeah.
And she were to stay at home, I would unconditionally want her to like make food for me when I get home from work, tired, like.
Okay.
Yeah.
I mean, it's okay to like want those things. Just find someone who's cool with that.
Yeah, I wouldn't just say, "Go make me a sandwich, you filthy woman."
Yeah, don't do
I
that.
wouldn't say that.
Yeah, don't do that. That's just mean.
Gold. Someone
What's
had
up?
a seizure in my class today.
Oh, that sucked. My sister used to have a lot of seizures. Yeah, those suck, man.
Like shit.
Yeah, did someone like put their finger in their mouth to try and like make sure they didn't like bite their tongue and stuff?
No, they didn't know how to do all that shit. I'm the only one who knew how to do that shit. But like, I was asleep.
Yeah, what was it? Chris Gill says, I like the traditional paradigm of mother at home, father working outside, but I don't think it makes women any less than man. Yes, exactly. I agree too, Kiss Killer. And again, I think what it needs to be a division of labor is what it is. And because I see this right now, even with all the kids I teach here on this stream. If kids don't have a parent at home, they kind of get fucked up. Like, you need to have someone at home taking care of the kids. Like, whether that means that there's a stay-at-home dad or stay-at-home mom, I don't think it matters. You know, like, whoever's making more money, go make more money, and whoever wants to take care of the kids, take care of the kid. But one person should at least take care of the kids, and one person should go make the money. If they're both making the money, no one's taking care of the kids. And if no one's taking care of the kids, guess what? I end up having to take care of the kids. And there's only so many of me. So, evolutionarily, everyone has, there's a division of labor. Yes, you can make the argument that women are more nurturing and emotional and whatnot, probably better as caregivers, whatever. Oh, cool. Like, but that's not all women. Like, I know some women that are just like boss ladies, whatever, and like they do very well in corporate, they do very well as lawyers, and like, cool, let them make all the cash, you know. And then whoever they marry, that guy needs to probably be a more caring, good with kids type person if they're gonna have kids. You don't have to have kids either. Like, you could just be together and both work, and then who cares? I just don't think it's fair to the kids. I don't think it's fair to have kids, but then both of you still try to pursue a dream outside of raising the kid. Because then just don't have kids. What's up, Bananas? Yeah, kids need parents. They do. I know. Kids very much need parents. I agree. What's up? I'm gonna end the stream soon here real quick because I gotta go.
I need parents.
You do need parents, dude. I know you need parents, dude. Like, what were you saying, dude? You had CPS show up at your door this weekend? What?
Yeah.
God damn it,
What
dude.
the hell is CPS, bro?
Child Protective Services. It's like what happens when the government determines that like your parents are.
ACS.
Oh, is it? Yeah. It's like if your parents are fucking up, like the government will come and like start doing things. It's not good.
It's fun.
It's not fun. It's very much not fun.
Resolved now, so we're good.
It has been resolved? Okay, good. I'm glad to hear that, Bananas, dude. I'm glad. You're not gonna go live with your mom? You're gonna still stay with dad?
Yeah, sadly.
Alright, cool, dude. Alright. Nice. You wanna play some Fortnite, Bananas?
Are we gonna play Fortnite?
Yeah, let's do it.
Bet.
Alright, cool. Alright. Thank you everyone for coming to Office Hours. Had a lot of fun teaching math and science with you guys. I also like talking about whatever. You know, this is cool. Come by the AMA on Thursday if you really want to chat it up about society and my viewpoints on things. I'm happy to do it at the end of the stream, too. Okay. Let me, what do I need to do? Oh, I need to start the stream. 1 sec. All right. Anyways, our next stream is going to be on Wednesday. That's an hour later. So that's going to be at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. Come on by if you got any math or science questions you want to ask. I'm happy to help you out. Or if you just want to like learn some stuff, like come learn with us, you know. I learned some new things today. I learned about like what the tree function is, or the 3 function. I've never heard of that one. And then I did some reviews of linear algebra. That's cool. You know, I hope you guys get it. I taught Noise some new things with physics. That's all cool stuff too. Okay, 1 sec. That's good. All right, now I need to raid this channel.
I asked a question. I'm not sure if you answered it or not.
Probably. Wait, did you post a screenshot of it?
No, I asked it in Twitch 2 times and.
Oh, my bad. Dude,
Yeah.
the Twitch goes like forever, dude. I can't. This is why I have the screenshot channel. It's because I can't read all the Twitch.
Yeah.
There's too much on the Twitch. Post a
I
screenshot.
couldn't get on Discord.
Well, you're on Discord right now.
The phone, yeah, right now I got home. The phone I
Oh.
had that I took outside with can't open Discord. I don't know.
Why
I
were you
downloaded
outside?
the app,
Why were you outside? What are you doing outside?
walking,
Oh, okay.
smelling the fresh air.
I fucking approve of that, dude.
That's dope.
I very much approve of that.
If you
Yeah.
want me to tell you I'll post a picture of how.
Yeah,
it
just post a
starts to
picture.
look.
I'll do it next time. You're good. You're good. One sec. Let me. Where's my stream manager? There you are.
The question was, what is cell theory? Because I heard that in I just today went to my first live meet. So.
Oh, for
we
your
were talking
school?
about-
For your school thing?
Yeah. Mondays is
Oh, because you're like
what is it
homeschooled, but you also have real school. as well,
Yeah.
right? Yeah.
geometry. I think not geometry. What am I talking about?
All right.
Chemistry.
If you want to keep watching us playing video games on the actual gaming stream, hang tight here in the Twitch. You're gonna get pulled over to actual gaming. That's our gaming stream. If you want to play Fortnite with us, please do. This is the whole point of it. Like, you know, I teach math and science, but also I find a lot of gamers through these video games, and that's how we get people into the Discord. So, come play with us. We have a lot of fun. Otherwise, I will see you guys on Wednesday. Enjoy the rest of your Monday. Enjoy the rest of your Tuesday. And we will see you there. Cool? All right. And if you're in the Discord and you want to still chat with us, there's a Recess voice channel down below. And I also stream the video games there as well. So they'll stream on Twitch, and they will also stream here on Discord. So just come down to Recess. You can open mic. You can talk to me, whatever, during that whole thing. I don't care. And I'm happy to talk about things. So, all right. I will see you guys there. Peace out.
Yo.
Yeah, what up?
Hey, can we speak? Can I speak? Oh my god. Can we speak?
Can you speak what?
Can we speak in